This topic 1 has then the has correlation to out rule. And an out rule has for itself a specific set of metadata, which then corresponds again to a content topic. Here, content topic 2 to 4. This screenshot, now you saw similar at the presentation we saw from Frank Müller. The red bubble is the in rule, and you see here, I point with a mouse, that there is again the relation has correlation to out rule, and you see here 3 out rules, and at the example of out rule 1, you see that there are correlated metadata, in our case here replace and maintenance and instruction. And so with this metadata, then the content can be reached. And the content actually you see here, the actual content you see here in the system. We have a screenshot from the spare part catalog where service technicians can access spare parts they need information about, and at this topic they can then at the same point see what content in the content delivery portal is available. Like Frank Müller mentioned, there are different source systems, and thus we have to model respectively to this source system differently. So we have our content from the technical communication side, which came from 2 systems, to source systems, and then we have the content from the spare part catalog. And my colleague Maurice Daum will, in the next presentation, go more in depth what this means for the Sparklet queries and API endpoints. For the modeling, it was important to notice that it can lead to problems if there are, like you hear in the screenshot, see metadata from different systems with the same names. This causes problems because there are different IRIs, so identification resource identifiers, but there are the same labels. For example, here, maintenance. And so a company needs to be aware of their IRI management at this point. And you see here a screenshot of Protégé. So we can only access one maintenance criteria, but we don't know which one we're actually selecting. Now we have gathered some recommendations from our experience. So it's generally helpful if you have some standards, for example, to facilitate the exchange of the out rules and also the development of Sparklet queries. Especially when you work in a larger team, it's important to have some naming conventions regarding the rules. And it is also very helpful if you have a good documentation of the rules, and also later for the testing that you have some standards, and so you can rely on that. And like I said, it facilitates the exchangeability. And what have been our results in the project, Julia will now explain to you.
Yeah, with the implementation of the semantic correlation rules, we have a completely new approach, which changes the process of content creation and content delivery in technical communication. the automatic generated deep links by classification, instead of manually setting hyperlinks, leads to a shift of required skills. So away from traditional technical writing to the subject area of content or information management. For this, it is possible to create a new role, for example, an information architect or a content engineer. Yeah. On this picture, you can see highlighted a manually set hyperlink to a correlated topic, which must be maintained also manually by a technical writer, for example, in a content management system currently. In comparison, here you can see highlighted our result of the project. These are automatically generated deep links, which are not maintained in the content management system. And then they are maintained from an information architect via the ontology and the semantic correlation rules. Yeah, and in the near future, we can imagine that it could look like in this picture, but this is still a subject for further research. No,
thank you again, Julie. During our project, we gathered some information, or we gathered some experiences about topics we need still to view more in depth at. One big point respects or is about the metadata of in and out rules itself. So imagine when you have maybe in an industrial context, you have a large amount of metadata, or sorry, of in and out rules, then you of course need to administrate these rules efficiently. And this, in our opinion, only works with metadata that the rules itself have. Another point which comes close to this is then the versioning of SCRs. So again, in an industrial context, it is important that there is a clear that there can be enabled a process how the rules can be managed and by whom, and that is clearly and transparent visible. There are some more conceptual questions we also need to think of. This is the so-called strength attribute. This enables to sort rules in dependence of their importance to users, and also the equals. The equals, they enable to constrain rules in dependence from their product they refer to. In the future, we can also imagine that these rules are not directly created or administrated in an ontology, but the ontology is in a larger web environment, and users only manipulate the ontology via the web environment, which would lead to less requirements or less knowledge on user side. Last, we now want to reflect the course learnings we had during these 15-week semantic information management course by Mr. Ziegler Sensei. we learned a lot about the methodical concepts of content management and content delivery. Oh, sorry, this was the pre-knowledge. And we have had, of course, what was important was pre-knowledge about database systems when it goes to graph databases, and also basics in programming have been very helpful. Now to the learnings. We learned how to model ontologies. We learned, of course, the concept of semantic correlation rules, how to model them, and last but not least, the basics of graph databases. We want to thank the company Liebherr, especially Frank Müller and Julia Scheibe, the system vendors, Quanos and Fluid Topics. Technical support was given to us by Florian Rommel. Many thanks for that. And also we thank the International Office of University of Applied Sciences Karlsruhe and the study program Communication and Media Management for travel and conference support. If you have any questions, don't hesitate to ask us. Move it down.
Yeah.
I'd like to start, but please stay here so we can answer maybe then together. So, Mr. Daum,
Yes,
you can
I'm here.
just start.
Can you
One
hear me?
second. Now you can start.
Okay. Wait a second. Can you see my presentation? Yeah.
Yes.
Okay. 1 second. So, thank you, Professor Ziegler, and greetings to Japan. Greetings to the audience and to whomever is attending via Zoom. In this presentation, I am going to go into detail on the technical implementation of semantic correlation rules via API programming for basic and extended processing logics. Because my fellow students, my fellow team members have already gotten into detail on the concept of semantic correlation rules, I am only going to give a brief classification of the contents of this presentation in the context of SCRs. After that, I'm going to depict the objectives of our research, followed by selected insights on the technical implementation process and a short summary in the context of our research objectives. In the end, a short outlook on downstream research that could and should be addressed, and my personal reflections on this research project. So when working with semantic knowledge graphs, semantic correlation rules aim to provide a generic methodology for mapping semantic correlations contained in the graph. They are designed in a manner so that basic and extended processing logics can be applied to the mapped semantic correlations. What my fellow team members already gotten into detail on were the sections 1 and 2, as well as the sections 8. And what I am going to focus on in this presentation is the technical implementation of an architecture which is designed to query the semantic knowledge graph for semantic correlation rules in the context of a given use case. So let's start with our research objectives. So we had 3 major research objectives. First, we aim to provide evidence on the general feasibility of technically implementing processing logics in the proposed architecture. Furthermore, a key point was to conceptually reflect on semantic correlation rules using our research findings. And last but not least, and also very important, as depicted, we can think of semantic correlation rules as a generic methodology to map semantic correlations inside a semantic knowledge graph. Thus, we should also approach the technical implementation of the processing logics in a generic manner. So now let's dig a little bit deeper into the technical implementation process. So in the beginning, there is a system which is sending requests to a REST API server. As already depicted in previous presentations, the requests are being triggered by the users of the respective systems. For example, when a user is viewing a certain content. These requests, they carry metadata defining the given use case. And what we want to do in the end is querying the semantic knowledge graph, respectively the graph database it is contained in, for in rules which are analog to the given use case, and then find out rules reflecting the metadata of the semantically correlated content. But before we could actually do that in the given project setup, some pre-processing of the input data had to be done beforehand, which I'm going to give a short insight on. So the input data in our case was in JSON format, and it has been predefined by the OpenAPI. And it is set up as a template with a predefined structure. And in the picture, you can see the key section of the request providing the use case specific metadata. And in this case, it is not filled, it's just the template. And when we have a closer look on the structure, we can separate two different types of metadata. On the one hand, metadata of intrinsic nature, and on the other hand, metadata of extrinsic nature. The thing is, semantic correlation rules do not address extrinsic metadata in the modeling process of the in rules. Also not as input variables for the query process. So in a first step, these two layers of metadata had to be separated. But be aware that we are going to need the extrinsic metadata later on in order to generate the deep links. We're kind of just bypassing the extrinsic metadata from the query. So what we end up with is just the layer of the intrinsic metadata. And this structure exposes another thing, and that there can be input from different classification systems, which is due to the different systems requesting, but there are even different classifications. There could even be different classification systems in one, different classifications in one system. So we end up with different types of requests filling the template, but leaving every other field of the template empty. In the pre-processing, only the relevant parts of the request object have to be filtered. So in the end, we get something similar to this, an object cleansed of all unnecessary structures. We end up basically with just key value pairs of metadata. So now that we have prepared our query input, we have a pre-processed cleaned query object, and we are going to use the containing parameters to fill a query mask. And the question is, how could such a query mask look like? And in order to describe how its basic structure is, we can separate the mask into 3 sections. It's still a single mask that is going to be filled in and that is going to deliver results, but just to describe it in a better, to be able to describe it better. So we have a input section, a SCR specific section, and a output section. Let's start with the input section. The input parameters are going to be filled into that section in order to find in rules that match the given use case. And at this point, we managed to implement one of the extended concepts in processing SCR, which is the combination handling of input parameters. And I am going to go into detail on that now. So what do I mean by combination handling? Imagine these input parameters. For example, a user has been watching content regarding the replacement of an electric switch. So it is obvious that if existing, a corresponding in-rule selecting these parameters can be considered as a match. But the question is, could there be any other matches? For example, imagine an in-rule that only selects the electric switch, but no metadata regarding the information classification. I think we can agree that we would consider this as a match as well. So we had to come up with a subquery to find all these in rules. But instead of going into detail of what's happening in the Sparkle, I'm going to show it and visualize it alongside the Sparkle, let's call it like that. So what we did in this subquery was starting off with the quantity of all in rules existing. But that's not what we are trying to find. So we had to filter, and we filtered by a subset where the in rules select at least one of the given input parameters, or even more, but at least one. The problem in this subset is that there are still in rules that select other metadata that is not part of the past set of input parameters. So we need to get rid of them as well, which is why we applied another filter to this subset, and we narrowed it down by only allowing selects which are part of the past set of input parameters. So in the end, we're getting exactly what we want, the combination handling of all given input parameters. And one interesting thing that we learned out of that is that after implementing the combination handling, we found out that the pre-processing step I explained earlier could almost be eliminated by just altering the Open API specification. So by just altering the definition of the requests object structure. This is because the main thing we did was separating the extrinsic metadata, but now we have combination handling, and we can even pass the extrinsic metadata into the query, and it would not result in the loss of in rules. The only thing that could happen is if somebody modeled extrinsic metadata on an in rule, we would also find this in rule. So it's quite interesting, yeah. And the result is that we can, by eliminating the pre-processing step, we can just have something like this given as request object. So in the end, just selects with IDs or labels, but even without the according keys. So let's continue with the other two sections of the query mask. I'm only going to give a brief summary of what's happening here due to the limited time of this presentation. But if you'd like to get a detailed look what's happening in the other parts, feel free to read the paper after its publication. So the second section deals with parts of the query that are only SCR specific, meaning they are generic and independent from any project context. And what's actually happening in this section is the retrieval of all out rules that have a correlation to a member of the found set of in rules. And what's then left in the third section is mapping the results to an output structure, which will be used in the post-processing step of the REST server. So as you can remember, in our case, the post-processing step was to generate deep links, and in order to do that, we need the bypassed extrinsic metadata and the out rules, respectively the selects of the out rules, which then will be transformed into deep links, aggregated, and sent back to the requesting system. What's happening in the post-processing step is quite project specific and dependent on what and how the requesting system is going, how the queries should be presented to the requesting system. So to summarize, in regard to our research questions, we found that the technical implementation for querying semantic correlation rules is possible with little effort and low complexity using the proposed architecture. A generic approach of implementation is possible as well up to a certain degree, but there will still and always remain project and company specific adaptations which cannot be completely eliminated in the process. And the last finding, this was the first practical test of semantic correlation rules in an authentic corporate environment. And this test showed no indications of a need to rethink semantic correlation rules conceptually slash methodologically. So what's the outlook? There were some approaches and a lot of research questions that could not be considered in the given project time of 15 weeks, but could and should definitely be addressed in downstream research, which is the technical implementation of further extended concepts of SCR, such as, for example, limiting the range of correlations, which is the equals you've learned in the previous presentation, and the ranking of search results, which refers to the strength attribute, also presented in the last presentation. And also pursuing alternative approaches regarding the technical implementation of semantic correlation rules, such as using different database systems and query languages. Yeah, and what are my personal reflections on this project? So what did I learn throughout the project? I came with basic knowledge in relational databases and with kind of advanced knowledge in JavaScript programming and the functionality and structure of web services. But what I learned was how ontologies work and how they can be used in the context of technical communication, how graph databases work and how to query them, then generally the concept of semantic correlation rules, the modeling and the processing of semantic correlation rules, and the associated tools we used, like or concepts like the Sparkle query language or the open source modeling tool Protégé. So yeah, that was my presentation. Thank you for listening. And also thanks to Liebherr, to the University of Applied Sciences Karlsruhe, and to Florian Rommel for supporting during the implementation process. If you have any questions, feel free to ask.
So you heard the applause. So it's thank you very much for these two talks here, which is now a very good extension of the technical side. So let's look in the chat. There's not much at the moment. Are there any questions from the audience here inside the hall? So if not, I would like to thank you again very much, both groups, and also to Liebherr for working with us in this first industrial use case. Thank you very much. So could you please stop the sharing?
So then we hand over to the second industrial use case. There's Brigitte, I already see her, and Eva. You can just start off, and I don't dare to pronounce your last name. So maybe just introduce yourself in some words. You can just start. Thank you.
Super. And you can see the screen. I just got notification. Is that correct?
Yes.
It works.
Yeah. Okay, good. Great. So we're gonna talk about first of all, greetings to you all, and of course we are very happy to present our practical approach to development of information architecture in the field of technical communication within mechanical engineering enterprise. And just a little bit about the company. Grundfos was established in 1945 in a small town of Denmark. And today it is one of the biggest pump companies in the world, with the purpose to pioneer solutions to the world's water and climate challenges and improve quality of life for people. My name is Brigitte Volsted. I'm a senior product information architect at Grundfos, more specifically in the product information management and the team of technical communication architecture and excellence function. My background is the Masters of Information Architecture from a university in Denmark. I pass it on to Eva.
Thank you. My name is Eva Nauert. I'm working as a content engineer at Grundfos, and I'm also the product owner for the content engineering area. I too have a Master's of Science from University of Applied Sciences in Karlsruhe. We know who's professor there. I think on my side, I only see the first slide of our presentation. Is the connection not so good?
Yeah, I am switching, but I just have really a conference link kind of stuck. So maybe I can try. I'll try reshare. I think that that should.
Yeah, maybe it is a good idea. Just stop sharing and reshare.
I might need to rejoin the conference because it's completely stuck on my side.
Then I could try to share.
Yes, that would also work. But I just cannot see anything.
Maybe that's a better idea starting off if Eva could share and just guide you through the presentation.
Okay. I cannot as long as Brigitte is sharing.
Okay, I have to leave the meeting then.
Okay. Then let's see if that works. That is, of course, a very nice way to spend time in a conference. Sorry for that. Okay. Okay. And now I hope you are able to see.
I can see your screen and the presentation.
The slide about us.
Yes.
Or yeah, okay. Then I don't see the Zoom meeting anymore. If Brigitte is back, please hear me.
I am back.
Perfect. Then let's dive right into today's takeaways.
Yes, so we will talk about the challenges with modular content, product information classification method by Wolfgang Ziegler, and moreover, how we implemented metadata in CCMS, how we trained the technical communicators in our organization, and then goals and the nice good win.
Am I the only one who lost sound?
Yeah, we lost her. So maybe could you, Eva, could you continue?
Yep, I will try to continue. So we are moving in the process of moving away from the document-based writing to topic-based writing, and in Grundfos we use data architecture. So the whole document is broken down into topics to increase reusability of those topic pieces instead of writing content over and over again. And we use a component content management system for that. And the challenge is then to find those topics again and actually get the benefit of reuse when working with topics. So the challenge we had, okay, how can we improve the findability of the topics to get reuse and to get a nice delivery online? So Brigitta, as product information architect, comes from this holistic view of information architecture, which is the art and science of organizing and labeling information systems to support the findability and usability. Information architecture consists of 4 facets, so to say: organization systems, labeling, navigation, and search. And it also reflects not just what it is, what the content is about, but also in which context it is used and who the users are, what do they want to get out of the content. So we can see nicely information architecture is the overlap of all those 3 areas. And so we were wondering, okay, this is a great holistic view, but how can we use it to develop the information architecture just for our TC area, our technical communication area? So for that, we used the PI class method by Professor Wolfgang Ziegler. And we used it because we think it's a very great tool to get a good definition of your topic and to show and control the reuse potentials. So we started off with the intrinsic classes, which we call component and information subject. And they are, as we see it, the most important classes for good content, because they define what should be inside of the content. And as soon as the writer wants to add something that doesn't really fit to this metadata frame, it is a signal that this information should be in a separate topic. So using these intrinsic classes really helps you to have clear definitions of your topic. Then by applying the extrinsic classes, we control the reuse. And here in Grundfos, we focus a lot on the product classes, on the extrinsic product classes, because there we see the biggest reuse potential. The extrinsic information classes are not so interesting to us at the moment. But very interesting for Grundfos as well are the extended classes, the variant properties and the functional metadata, because Grundfos offers a lot of its products in different sizes, in different materials, with different features. And those, of course, are reflected in the content as well. So how did we then actually develop our metadata structure?
Yes.
Okay,
You're
back.
So the first step, of course, was to locate the right product hierarchy within organization. And we are quite big. We have more than 19,000 people working all over the world, and we have a lot of data. And of course, we first investigated into already existing product hierarchies, product taxonomies, and we found a sales hierarchy that was static and maintained in a way that didn't suit it for us for this project. And then we stumbled upon a marketing taxonomy, which we then decided to synchronize and use using RESTful APIs. And that is a product taxonomy that is exposed to our customers when they go on our website and select the products that they want to purchase. Then, of course, a click and the next step was to locate component hierarchy, and that really did not exist. We have looked into our ERP system and we got an extract of 3,000 components that we realized not all of them are really relevant for the content. We do not.
I will just take over again. I think we lost her again. So not all content components that we have in our ERP system are relevant for the content. We could see that because we did an analysis of some of our contents, and there we can see that the components that are actually mentioned, that's only a few. But still, we cannot do an analysis of our complete content because that would take us years. So we decided to take the list from our ERP system and compare it against the translation memory to see how many components are mentioned in our content. We then validated those components we found with our technical editor. So they checked that it is the correct terminology we use. And then we had a nice list, hierarchical list of our components that we use. For the information subject, the intrinsic information class, we also relied on the content analysis, but as I mentioned, we only had very few documents that we looked at, and therefore we couldn't say that these information classes from that analysis are relevant for all of our products and documents. So we looked top down. What do we have in Grundfos? We have what we call a list of headlines, where we define the first and second level of our documents. That is applicable to all of our documents, but the depth was missing. So then instead of investing into content analysis that took us 2 years or something, we decided to look around what's already out there, and we found the IIRDS standard. And they have a nice list of most information classes that are relevant for technical documentation. And so we took that, compared it with what we had from our analysis. We crossed out what we didn't need in Grundfos, and that's how we got our information class. So with these 3 classes, we covered the basic classes, as I called them before, and they are applicable only on topic level. Next step is then what we call content configuration, where we also look closer inside the topics to get more reuse out of that, and where we investigate further into the extended metadata classes. So there we held interviews with our technical communicators, our technical writers, and asked them how often they come across this variant property specific content. So how often do you write, this is different because of this material, or this is only applicable for this feature, to get an estimate of how much of our content was depending on these variant properties. As these variant properties come from the product itself, we also looked into our product configurator and looked what data they have and in what formats they have it. And from that, we can see that this is very, very complex. Our products can be configured in up to 100 parameters. So this is a huge, complex task. And then the challenge we have is A, what is relevant for the author or the user, and B, how to manage that complexity in our CCMS. So this is the next step we are looking into. And the question is basically, okay, we have our classes, we have our metadata lists, how to implement those in our CCMS.
Okay, I hope I now downloaded the Zoom, really a lot of issues, but then of course a natural idea was how do we implement it, and how do we implement it in a smart way so it is not a static structure that can scale and grow. So we have investigated several solutions on the market, but nothing really suited our needs or was not that impressive as we thought. Therefore, we decided to really develop mechanisms in-house. So the process as is today is that information architect and content engineer is maintaining the metadata list in the open source Protege ontology editor. And we also sync our original enterprise product hierarchy into the system too, into the structure. And then the in-house developed metadata tool allows us to then put that structure into our CCMS, where then technical communicators can easily access and tag content using this structure that we have developed.
And then from that, the question came, okay, now we have our metadata in place. How do we train our communicators to apply it? And for that, we started with a theoretic seminar, so to say, because most of our technical communicators, they don't have a formal education in technical documentation. So to get a common ground, understand the reasoning behind metadata, which metadata to use and how we build it up, we first had a theory session. Then we tried to make it more interactive and practical. We worked with smaller groups of our writers and just showed them topics and say, okay, how would you tag that? What object is mentioned here? What information is contained here? So to get them thinking in the metadata way, and especially in the intrinsic class metadata way, because as I mentioned before, that's really important to get the content right so that the metadata fits the actual content and the other way around. To make it even more easier, we said, okay, it's okay if only new topics are tagged for the beginning, because we come from migration, not all of our content is fit for topic-based writing. So we will stick with newly created topics for now. And the goals we wanted to achieve with tagging our topics with metadata. For one, increasing the findability of our content and therefore the reuse within our CCMS. So to increase the efficiency of our technical documentation. We also, of course, want to validate that we are actually reusing and that we are not creating double work. So we use analytics inside our CCMS, and that only works, of course, with metadata. And metadata, like the PI class, that is the basis for intelligent solutions, like, for example, semantic correlation rules. And we will hear more about how semantic correlation rules can be implemented in the Grundfos content by the next presentation. And I think with that, we will close it down to not take more time.
Thank you, everyone.
Thank you. And sorry for the technical issues.
The browser would just freeze constantly, but
so maybe you heard the applause here. So I think people were very satisfied. Thank you so much. Just to let you know, it's a little difficult here handling the speaker and the microphone, so sometimes there's a little delay in it. So thank you very much. So is there any question from the audience here about Grundfos and their products? Maybe someone want to buy a product or something? I don't know. So if not, I was directly handle over to the group, which is going to present right now and shows what they did with your data. Okay, so you can just take over your presentation's right there. And
So, hello everyone. I hope you can hear me. I would like to welcome you to our talk, which is about the experience we had during the implementation process of content correlations using semantics and query technologies. Our research the past semester focused on implementing semantic correlation rules to an existing metadata system. Our team, consisting of Alicia, Marta, and me, we had the pleasure to collaborate with Grundfos, the pump manufacturer that you just got to know. At this point, we would like to thank Grundfos for providing us with all of the data. Before we talk about the agenda, I would like to start off by describing a really common issue that is often found when working with manuals and introduce you to a possible solution. The field of technical communication has changed a lot the past 20 years. While 20 years ago, best practice was to deliver statistical manual in paper form, we can nowadays look for technical information that has been subdivided into smaller topics in content delivery portals on our smartphones. We can classify those topics with metadata and create an individual output. Oftentimes, we encounter the following dilemma. If we are seeking for a solution of a problem, a single topic most likely not provides enough information as it lacks context. On the other hand, the complete topic assembly is way too much content in order to resolve our specific use case. And this is where the concept of microdocs comes to play. Microdocs are a structured set of topics with content-relevant content that is just enough to fulfill the purpose. Those individually composed topics take into consideration the user need and the user context. Practically, this means that if a service technician is looking for information about how to properly connect an electronic device in the service manual, the CDP would only display relevant topics, packed in a dynamic microdoc. But what we did is we tried to go a step beyond and consider adding certain rules to the use cases, which help to anticipate the user need with the help of an underlying ontology. Those so-called semantic correlation rules apply to an intelligent logic and automatically display content-related information in the form of clickable deep links. The big advantage is that those links are not manually created, as this implicates administrational effort, but they are formed automatically based on the underlying ontology.
Thank you. Okay, now follow with the agenda today. Our agenda is chronologically corresponding with our investigation process. Let's have a quick look before we start at the workflow and the toolchain. I would like to give you an overview over the entire workflow. During the implementation of the use cases, different softwares were used in the following. We will show you those and we will deal with the steps 1 to 4 and the step 8. So let's start directly with the first step, which is the ontology editing.
I would like to show you what primary work has to be done so that we can proceed with the data of the ontology. Microdocs are to be understood as a dynamic document that is non-chapter oriented. In short, it is a networked association of independent topics or other information objects. Here, as you can see, one folder stands for one topic of an operating manual. For example, there is the topic safety instruction and another topic called connecting, which contains information about how to connect a certain product. In order to use microdocs, some requirements must be met. First, we have to classify the objects according to the PE classification. Here you can see the results of the PE classification into the categories, component, information subjects, and product. And now the content of the database is classified and divided and labeled with metadata. As Suzanne told us in the introduction, we would like to have a connection between these two topics. And for the implementation of this relation, it is necessary to use an ontology editor. And we use in this project Protégé. And Protégé is a free open source ontology editor and a framework for building intelligent systems. The metadata classification is shown here on the left side, on the right side, and of the screenshot. And the contextual information is connected by semantic relations, which are defined in so-called in rules and corresponding out rules. And for the in rule, you have to select the relevant metadata for the use case of the starting point, and then you have to choose the corresponding out rule. And for the out rule, you have to select the relevant metadata for the use case of the endpoint. And as you can see here, this is now Protégé. We selected the metadata connection and product for our use case in the in rule 1, and have chosen the out rule 1 as correlation.
Thank you. I will now proceed to show you how the ontology model is integrated into a graph database, GraphDB, and how the database queries are formed. The GraphDB is a database and knowledge discovery tool which is compatible with RDF and Sparkle. The database uses graphs to represent and store highly interconnected information. In GraphDB, a visual representation of the metadata can be created using the visual graph, as you can see on the left on the slide. The image on the slide shows the class SCR and the subclasses in-rule and out-rule. It can be seen that the use case 1 is connected to both of those classes, in-rule 1 and out-rule. Here you can compare the visual representation of the map from the GraphDB and from the previous shown data on Protégé. And although both of the tools are suitable for the purpose of database programming, we decided to form the relations in Protégé as it is intuitive and simple in the handling. And however, we preferred the visualization in GraphDB as it is illustrated more clearly. The two nodes in rule 1 connecting product and out rule 1 connecting product safety instruction can be folded out. Here you can see the metadata that selects the two rules. The nodes of the rules are connected with the metadata via commands. For example, in rule 1 selects the component product and the information subject connecting, and out rule 1 selects the component product and the information subject safety instruction. Both rules are connected by the command has correlation. Afterwards, we developed the database queries with Sparkle in GraphDB. We used the editor to insert our Sparkle query, and the table below shows the result of this query. Let's have a quick look at the query and the results of it. The shown Sparkle query is composed of 3 parts. First, we've abbreviated the namespaces by prefixing them with abbreviations. Select the things, list the variables we want to output. As a result, we want the name of the use case, the out rule, and the metadata which the out rule selects. Then we filter the data according to various conditions and dependencies. Yeah, and here you can see the result. The data that the Sparkle query selects is visible in the table on the bottom of the screenshot. For an easier overview, the name of the in rule, the out rule, and the metadata are displayed. And furthermore, the table shows which metadata the out rule 1 selects. And in this case, it's the component product and the information class safety instruction. I would now like to give you a brief insight to what happens next in the background. So let's have a short look at the workflow again. So step 4 to 7 was mentioned by Maurice Daum and Florian Rommel. So we'll now go to the result of the display and from the semantic correlation rules, which is for our use case in the CDP fluid topics.
Okay, here in the screenshot, shot or the screenshot shows us the fluid topic CDP with the content of Grundfos. Here in the middle is the content, and on the right side we will see correlated content. And as the API search for a topic with semantic correlation rules like connect and product, it generates on the right side the clickable deep link. Okay, we can't see it. And now we can read a safety instruction and requirement for electrical connection. Another way to get this information is we can use the facet search. As metadata is selected via the filter facet, the topic it will show the correlated links. And here you can see a possible display of the correlated content. Next to the topic, you have the heading and a short description of the correlated content. The links are generated automatically through the underlying ontology and the relationships between the metadata.
So to wrap up our presentation, we would like to conclude with our key findings and our takeaways. Over the course of the semester, we encountered various challenges. One of our main problems was the lack of programming skills in our group. Especially for the API programming, knowledge in database programming is essential. We started with almost 0 skills, and with the help of our colleagues, we managed to do at least the basics. For further optimizations, elaborated skills are really helpful. However, we were satisfied with what we achieved with the skills that we were taught in such a short period of time. Secondly, we noticed that a good basis of metadata structure facilitates and accelerates the process. This means having a well thought out and consistent metadata concept is crucial. During our research, we noticed how small inconsistencies in the classification of the metadata can be an obstacle in the implementation of the rules. Lastly, we learned that not everyone needs to have the same skill set. Each team member quickly took over a fitting role, and we complemented each other pretty well. Also find the tools we used during the whole process on the slide.
Okay, and now it's interesting to take a look at the extent to which is this preliminary work transferable to other companies and other use cases. As you can see, the main effort is required for the ontology modeling. In order to create the semantic correlation rules, a well-structured, consistent classification of the metadata according to the PI classification is required. If the company has a well-developed metadata system, the semantic correlation rules can be established easily and quickly. The complexity here depends on the selected use case, for example. The SQL query and the API programming can be adapted to a changed ontology only with a few changes. So the amount of work and time required for this is quite low. And all in all, it's worth putting more time and effort into the ontology and the creation of the use cases so that the queries later are easily adaptable.
Okay, now we would like to give you a short outlook about tasks which we could not finish and which are then still pending. In the first place, it would be interesting to continue modeling more use cases and refine those use cases, which means creating more out rules for each in rule in order to establish an intertwining system. Another possible optimization is including the possibility of ranking results, which means refining the strength of the results. This arranges the results depending on the importance of the specific use case. Depending on this use case, out rule 5 might be displayed before out rule 3. As for now, the results are displayed by ascending numbers. A further aspect, which at this point of time is still not possible as we lack of mass data, would be the integration of an artificial intelligence, which analyzes the user behavior and anticipates possible use cases fully automatically. All in all, it has been really interesting, the research semester, and we enjoyed the research. Thank you.
So thank you very much to this group. Just one question from my side. How much did you know about the product itself? I mean, it was like liquid pumps, so how much did you know? Because this would be the underlying question. So if you define such a new, let's say, profession as an information architect, creating from AI and from use cases, and the rules or something similar, how much do they have to know about the product? Is it, and maybe also Eva and Brigitte can contribute to this. So maybe first the answer from the group. Do you think that, how deep should be the knowledge and level of knowledge to understand the product itself? Mm-hmm.
I guess it's the same for the use cases. If you do not understand the use case, it would be a problem to enter the queries. So you have to know a bit more than the metadata. You have to understand the product.
So Eva, Brigitte, could you maybe answer this also? Maybe open up the microphone, because this is more or less the work you're at the moment doing. You're modeling a lot in the ontology. How much product knowledge is really at the end necessary?
Well, I'm not an expert in pumps. That's why I'm a technical communicator, not an engineer. I mean, you need to get to know the products and how they are built up in a general way, and then for each use case, or to get more specific use cases for a certain product area, it's beneficial if you know a bit more about it. But of course, you also need to keep in mind how the user interacts with it, and that would require some user feedback investigation, so to say. Yeah, you don't need to be an engineer, but you do need to know a little bit how the stuff works.
Yeah, that's right. I would also agree. It's more of a collaborative process, and you need different experts from different areas. So yeah.
Right,
User
so thank you so much.
Yeah,
so
thank
again,
you.
thank you to the groups, the first two industrial cases. So I would like to come to the last industrial use case, and maybe you've seen before shortly Julian, which comes from this company donating the use cases. He cannot be here in person and had not so much time, but maybe Julian, if you're still there, maybe at the end of this presentation of this use case, you can say just some words. All right. Okay. So
sure.
Oh, hello everyone, and welcome to our presentation about ontology modeling and the testing of semantic correlation rules. So first things first, we have a small introduction. My name is Leon Brecht. My project role was basically the extraction of metadata and faceting the content later on in the content delivery portal.
And also the development of use cases, SDR and Sparkle. So everything semantics and ontology, that is my kind of field.
So about the project, as already mentioned, we were in cooperation with Pretax Ulmer, a company that is known for building infant carriers and trolleys for babies. The circumstances why they were interested in doing this project with us was that they had an interest in content delivery and also in the semantic information management for future applications and building knowledge graphs. Resources we used from them were a big XML file that was an output out of their CCMS, so their component content management system. And this included all the content topics, basically the manual of a product attached with the metadata hierarchy. Tools we used were ETLTC with an editor, the Protege editor to build the knowledge graph database in order to later on store this information from Prodigy, and WordPress. We have divided our project into 3 stages. The first stage would be transforming the metadata into an ontology. The second step was developing the semantic correlation rules. And the third step would be implementing then the semantic correlation rules into our content delivery portal of WordPress.
Yes, so without further ado, I will start with the first step. As Leon already explained, the resource that we got from Pretax Ulmer was a huge XML file with a lot of information in it. But to actively use the metadata that was in this XML file, it needed to be an ontology. Usually in projects I already conducted, I would do this manually. But as you can imagine, doing this by hand is only possible if it's a really small metadata taxonomy. So the more metadata you have and the larger the product range is going to be, you don't really want to do it manually. So I was really interested to see how complicated it would be to use XSLT and transform the information we have in the XML into an OVL file so we can actively use the metadata for semantic correlation rules. So from metadata in XML, which roughly looked like this, as you can see, it's not really clear what's going on, but we have all the nodes. Those are, for example, the information classes that are used. And they were just written down straight in XML, so you can't really use it to connect anything. So I used XSLT to go from this, as you can see, to this, OVL classes and OVL individuals. Depending on what I needed, I decided spontaneously what tags in the XML were going to be classes and what tags I want to be an individual. How this looked in the XSLT, I will show you now. So here is a small excerpt from the XSLT. As you can see, I work with XSL for each. So you can imagine for every tag that I wanted to be an OVL class or OVL individual, it roughly looked the same. So I start with selecting the XML object. In this case, it's called group. And I open up the OVL class tag inside. With the help of Concord, I was able to build the URI. You can see just in the last, like here, you can see I'm calling the add name from the XML object group. In some cases, it's an ID, in some cases, a name. This is important, so we have a specific URI, and we can later on in the class hierarchy identify the object and use it. Next, with the RDFS subclass of tag, I'm contextualizing the class within the hierarchy. So by doing this, I'm able to build a hierarchy out of the XML data. As you can see here, I'm always going 1 position up, so the right parent node is selected. And as of last, I'm using RDFS label because, as you can imagine, if up here in the URI is just an ID and not a name, it is really hard to handle the ontology and the information. So it is important to give it a label. Here, I'm just selecting the display name of the XML object, which has a clear name, so you can later on work flexible with the ontology. Yes, so now that I had an ontology, an OVL file, I could start working with it, which meant in this case, adding the semantic correlation rules. Pretext Römer, as Leon explained in the beginning, was not really familiar with content delivery or semantic information management. They have definitely interest, but so far they didn't really had a lot of projects going on in this topic. So we got the possibility to analyze the product documentation as the first people and start finding some use cases. So I took my time and really read through the documentations that they gave us, trying to imagine I'm a customer of Pretext Römer and I'm reading the information and I'm searching for something. And at some places, it was quite clear where information was lacking. And at those pain points, I decided to identify the use cases, and with the help of the use cases, I could start developing the SCR. And by that, I mean defining which metadata set is going to become an in rule and which out rules are going to correlate with this in rule. Just to show a quick example, the previous groups already showed you a lot of SCRs, so I'm just going to keep it quite short here because I think you already know a lot of it. Here we can see the in rule. It selects 2 intrinsic metadata and has a correlation with 2 out rules. Down here, you see the out rule. Now, the out rule doesn't correlate with anything. It just selects the metadata. Something the other groups did not yet implement, but we tried using is the data property strength. I think some groups already talked about it. This is to sequence the information in a specific way so that the deep links are not just slapped into the CDP, but have a very specific sequence, which in some cases might be important.
Yeah, so let's now come to step 3, implementing the semantic correlation rules into our content delivery portal. Right here, you can see a small excerpt of the knowledge graph in our graphic database. You can see the different in rules with their correlation and the metadata sets attached to those rules. Right here, we have enlarged a small snapshot of it. You can see the in rule attach isofix. It has the metadata attach and isofix, the product, and the correlating out rules with it. As I think most groups before us already mentioned, we also used Sparkle in order to get information out of our knowledge graph and query the different metadata. We have just, kind of brought the whole Sparkle thing into our own structure for what we needed with our in rules. And then on the bottom, you can once again see the different metadata of this in rule example. Right here, you can see an out rule example of how it looks like for us. And as Marielle already mentioned, we also tried out the data property of strength, which allowed us basically to order the different semantic correlation rules and the SCRs by our own design in order to possibly bring them into a structure where the user can then really see the different steps that are needed in the right order. Here you can see a small snapshot of this. For example, the strength 20 then selects whether this whether this semantic correlation rule is where this is displayed. Once again, we also used an API in order to communicate between our content delivery portal, which was WordPress for the Pretext team. There we are faceting with our metadata. This metadata is then sent into our API. Through our Sparkle, we then query with this metadata in the content delivery portal what sets of metadata are correlating in our knowledge graph and bring these back as semantic correlation links back into our content delivery portal. This will then look something like this. We have on the left-hand side, we have our facets, our faceting metadata, which you can see right here. We have check with the content coming as check before use for the product, and the correlating, the semantic correlation rules are then on the right-hand side, and these are the correlating metadata brought out of the graph database for this, out of our knowledge graph. We will show you the whole system in the next presentation a bit more, and we will have a bit of a live demo.
Yes, so now I want to draw kind of a conclusion like the other groups, some lessons learned and some things to consider in the case some other students want to do projects like this. I just wanted to go back to all the tools we used that we mentioned in the beginning, and want to go a bit into detail what kind of skills were necessary or were beneficial and what we learned. So first, ETLTC. As you saw, it was not a lot of work to implement the ETLTC. In the end, it's not a huge script, but of course, I needed quite some time to research and really look into it, and a lot of versions until the OWL was finally accepted by Protégé. But I would say that just basic skills are enough to go into this project, because if you have a basic understanding of ETLTC, you can already start researching and working right away with no bigger problems. What I think is a bigger pain point of projects like this is OWL and ontologies, because I feel like if you have nothing to do with ontologies or OWL and you don't have a basic understanding what the resource description framework is, you will need a lot of time to get into it. And in my experience and what I heard from my colleagues, this was usually the part where people really try to read into, watch tutorials, try to find out how this whole class hierarchy thing in Protégé works. But in the end, I would say that after this project, I think everyone will go home and finally understand what Professor Ziegler is coming up there and why it is so much fun to work with that. With Sparkle, I have to say, as you saw, the script was also not that big. It is beneficial if you know SQL, because the syntax is quite similar. You get more easy into it. We had the luck that we already knew SQL in some basics, so it was not a lot of work to research and start with Sparkle. Down here with the API, WordPress and CraftDB, I don't want to go in too much detail since there was not a lot of work that I personally did or that was too overwhelming. But I definitely want to know more about the API, since just our colleague Florian Rommel put a lot of work into the API together with Maurice Daum. I hope that maybe in future projects I will get a deeper insight into what actually is going on and what those two guys are building up there, because I think it's one of the most important parts of this whole project and this whole thing we're trying to create. But I think you don't really need API knowledge if you have great guys like Maurice and Florian.
Then let's give a short outlook. The first one would be we would find even more effective ways of use case harvesting for this project, find more use cases, connect more metadata with each other in order to create more semantic correlation rules. A second step would be developing even further sparkles for maybe more varied results, or even more results and better results. A third step would be researching possibilities to standardize semantic correlation rules, since, yeah, well, there's always room for standardization. Whether it would be possible to do such thing in a company environment is up for debate, and we will probably see in the future. And as a fourth point, we would conduct tests with a broader product range and bring even more products into this to create a bigger knowledge graph, see maybe what information and what metadata correlates even across product ranges. Thank you very much for your attention. For any questions, we will be here, or you can reach out to us via our email.
So thank you so much for this first talk regarding the products use case. So just let's see. No, there's no question at the moment in the chat. So maybe what I didn't mention clearly enough. So this group had to deal with a situation where they developed an open source delivery portal, which is a quite unusual thing. So it was something which was like a bypass to the other work because they had to do additional work. So I'm sorry for that. But I think it was quite interesting. And for me, for myself, was another research question which I addressed to you. If it's possible to use this software as an alternative to commercial ones. So maybe you can say at the end something if we should continue this. But maybe first, let's go over to the last group. So please. So just so you.
Hello again. Here? Okay. So again, hello everyone. Welcome to our second presentation about content delivery based on an open source implementation of WordPress. You already know Leon, but now I would like to introduce myself too. My name is Alexa Becker. I'm in the first master's semester of the University of Applied Sciences in Karlsruhe, where I already made my bachelor's degree in communication and media management. And yeah, this is Leon. So let's go to our agenda. First, we would like to explain our motivation to do this project about creating an open source CDP with WordPress, and explain why we would even choose WordPress as a CDP. Afterwards, we're going to talk about our project flow and how we work during the project. Afterwards, we're going to show you a live demo and give you a little conclusion. So why would somebody create an open source CDP? First of all, you can say you have less costs for an open source CDP if you compare it to a ready-to-use CDP from a vendor. And another point is that you have no dependencies on vendor-specific system functions, like, for example, file formats or something. Yes. Another point would be the possibility to customize your CDP on your own, like you wish that it looks like. And another point for us was to test the limitations of WordPress, since it was not the purpose of WordPress to be a CDP, since it is a web content management system. Yeah, but why WordPress?
Yeah, well, why was WordPress chosen for this? The one thing is it is a customizable open source web content management system, which we wanted to kind of change into a customizable open source content delivery portal. You can use HTML and CSS to customize it. Both of these things we were in contact with during our undergrad program before, so we had some insights into both these things. Another point that makes WordPress attractive to try such a thing was the broad and diverse community. There are a lot of people working with WordPress. There are a lot of different plugins. where we thought there might be something we can use, maybe even save some time through a plugin or two, which in the end kind of worked out in some parts. And another a bit smaller part was that we all had easy access to it via the internet, and we could all easily join, so it was nothing local.
Yeah, now more to the project flow. Prerequisite was to analyze the data the company Breakout was providing to us, because we had to know how the content and the metadata we got was structured. Since we could not just upload the export file from their CCMS into WordPress, because we had to transform it into another file. So the first real step was to find a data format for the WordPress import that makes it possible to import the content with the metadata, so no connections get lost. The second step was to extract and create modules that are tagged with the attached metadata out of this export XML file into another file. And the third step was to extract the metadata and build a hierarchy where the modules could be sorted in. And the fourth step was the actual import, and afterwards the styling with CSS.
Yeah, so a bit more into the whole transformation process we had with ETLTC. As already mentioned, we got a huge XML file of basically the manual of a product from Breakout, from Julian Stehle. And this XML file then contained the contents and the content tag with the metadata sets, and also the big metadata hierarchy, which basically organizes this metadata attached to the content in order to organize it and give it a structure. We then had to build two XSL transformation files, one just extracting the metadata hierarchy, since we needed to use that to build the facet inside WordPress for our content delivery portal. And we also needed the content and the content built in topics tagged with the metadata.
So now back to the transformation of our content and the metadata. We had to transform our content, as I already said, and we used RSS as our import file for WordPress. RSS was a file format for blog posts for WordPress, and we used it for our case to transport our content as an HTML in this RSS file. There were some pain points, of course, during the project in this step. First of all, we had to understand the content structure that came with the content in this file out of the CCMS. This was a little bit complicated because, like you can see on the screenshot, there were some elements that were not very easy to transform. For example, list elements or pictures, because there were many attributes and elements to consider and take into account. Another problem was that sometimes, for example, image paths weren't all in the same standardized way in this file, so we still have some issues showing these pictures. And in the end, of course, XPath was a little problem because you always have to find the right section to trigger that your content comes out in the end.
Yeah, and to the metadata hierarchy, there were also some pain points, as you can imagine. We have actually built two metadata hierarchies. Since we tried out some things, we also tried another file format till we switched to RSS. And yeah, as Alexa already mentioned, there were some XPath pain points to find the correct nodes inside the whole XML tree. There were also some problems with, yeah, well, getting the result we wanted and filtering out things we don't want to have in all of this. And another pain point was some classic coding errors, I named it, since I invested quite some time somewhere looking for a mistake in my logic, and it was just somewhere then, yeah, well, a bracket too much or too little. And yeah, so it was actually, I think for both of us, I'm speaking for both of us, at times a bit frustrating working with this and getting it to work. But in the end, we managed to, yeah, well, create both the things we actually wanted to have, the metadata hierarchy and the content tagged with metadata. And we then imported it into WordPress. Important to know was that we had to import the metadata hierarchy first, since it actually builds the tree where the with the metadata, where the content and the metadata with it is then structured into or organized by. If we wouldn't have done the metadata first and we would have used the content, we wouldn't have had the correct structure levels of metadata with it. Yeah, well, the import process also had some pain points here and there, but in the end, I think the product can speak for itself. And yeah, in the bottom you can see a small, yeah, kind of snapshot of how it looks like without the real application, but we will come to that shortly.
So now that we have imported our content and metadata into WordPress, we could start with styling and formatting the content and the websites. And therefore we use different widgets in WordPress. And we also prepare different classes during the XSL transformation into the RSS file. And then we could easily select the elements we wanted to style. And yeah, we also use CSS to show or hide metadata or elements we needed in WordPress. So, oh yes, what we learned. So our conclusion of this project was that we have now a deepened knowledge in XSLT, of course, and we gathered much experience through the work on a real software project we are really proud of. And sometimes it was a little bit stressful and a huge bit time consuming, but yes.
Yeah, so on the left-hand side, we kind of made a pie chart, which was not really, we didn't really measure the time we invested into all these things you can see right here, but it was more our feeling of where we invested the most time into. And as you can see, XSLT was a big part till we actually managed to get everything to work and to have it look the way we wanted it to. CSS was a part of it, bug fixing was a part of it, and the whole import process was also a quite big part. Another point that we wanted to share with you what we learned were that we had to find compromises, things we had to scratch, things we had to think anew, or just not try to be perfect with, but rather get something to work. And also another point was that it was quite rewarding when something worked. And yeah, so much to that. Now we'll come to the live demo. Let me just stop the screen sharing for a second. So, as you can see right here now, this is our WordPress content delivery portal, the final product we came up with now. On the left side, you see the metadata facet, and the faceted metadata right here would be check. You see the content that is displayed by using this metadata, which is check before use. And you see on the right side the semantic correlation rules, which are crawled by or queried by our Sparkle and API out of our knowledge graph. You can see adjust headrest would be the semantic correlation rule with the strongest strength property we have set. And up here in the top, you can also see the different metadata in the link of the WordPress. So if you just click onto the adjust headrest link, or rather the semantic correlation rule, we jump to the adjust headrest content topic with the faceted metadata right here. You can also see the different or the metadata set up here once again in the URL of our WordPress. So let's jump back into our presentation for our final thoughts. We want to thank Julian Stehle from Britax for the Q&As and for the background information of the metadata. We want to thank Mr. Professor Ziegler for calming us down when it needed to happen. And we also want to thank Florian Rommel for the help with the WordPress content delivery portal and the help with our API. Thank you very much. And should I already answer the question you gave to us in the last presentation? So just to bring it up once again, whether we think this whole WordPress content delivery portal would be something that people can work upon. As we said in the beginning, there are no real costs for using this right now, this WordPress content delivery portal for us and for a company. But of course, a company would need workforce in order to build this. And since time is money, we think in order to give it the whole structure that the company would need, it would be quite expensive. So yeah, well, companies building content delivery portals still have their points with their systems and can be probably a bit more relaxing for the people working.
Looks like a typical answer. It depends.
Yeah, it depends.
All right, so thank you. So let's see if there's something in the chat. So anyone else who wants to ask something from the audience here in the lecturing hall? If not, I would give Julian, are you still there? The opportunity maybe to say some final words. There you are.
I'm here. So yeah, great job. I just want to say thank you to you, Wolfgang, to initiate this and to make it possible to get this done. And big thanks to the team, to Marielle, Alexa, Leon, and Florian to support this. Great job, and I'm really looking forward for next steps to figure out upcoming use cases. Yes, you identified the first one when our consumers are having already installed child seat in the vehicle. But as a giving starting point is how do I want to install it? Maybe, yes, all checks are done, but still I have trouble, so kind of troubleshooting and further on. So I'm really looking forward to yeah, get this POC yeah, developed in further steps, and looking really forward to yeah, further maybe projects with you, Wolfgang.
So thank you so much also for this cooperation, but be aware next time the students will do the work for you with WordPress, you have to pay for this, you know? It's freeware,
sure.
But the students are not free anymore. All right.
Sure.
So maybe my last personal comment, maybe I was honored the most when the students approached me and asked if we could continue such a work also in the summer. And this is probably what we do in a different way. So a more extended one, and it was quite good. So I think everybody had some quite some fun, and we all made some experiences. So thanks to everybody. And I think this would be the closing of today. If not, Debo has something. No. Okay, so thanks to everybody. So please. Thanks to the audience. See you.